Alright, hi year 11s, this is Mr. Lim here again, and this is our 9th video on chemical bonding about covalent molecular electron dot diagrams. Okay, so we're going to learn how to draw covalent molecular electron dot diagrams. And it's hard, and it's fun. Alright, so electron dot diagrams for covalent molecule substances are built by the following steps. There are many other ways to do it, so if you find one that you like better or that works better for you, then please use it. Okay, this isn't the only way, and eventually when you get used to it more, you won't have to do this. You'll start recognizing patterns yourself. All right, and so we're going to do a couple of molecules. We'll do H2O, NH3, CO2. Let's do H2CO. Oh, no, not that one. I wanted CH2O, HPO, POCl, and let's do C2H4O2. Okay, so we're going to draw all of these out one by one. Hopefully we'll see how we go. All right, so let's have a look. First of all, we're going to list out the elements present in the substance and determine how many electrons are present in their outermost energy level. Okay, so I got hydrogen. It's got 1 electron in its outer shell because it's only got 1 electron anyway. All right, so that's how many it is. All right, and we're doing H2O. Okay, and then we're doing oxygen. So we should recognize that oxygen has 8 electrons, 2 in its first shell and 2 in its first energy level and 6 in its second energy level. So it's 6 electrons in its outermost energy level. All right, so that's the first step. The next step is determine how many electrons each element present needs in order to get the full p orbital. So hydrogen is a unique one because it only has to fill the 1s orbital, so it only needs 1 extra electron. Okay, it doesn't need to fill the p orbital in its energy level because it doesn't have a p orbital in the first energy level. So hydrogen is unique, it just needs 1 electron to fill the 1s orbital. All right, oxygen, it needs 2 electrons to fill up its p orbital to end up with 2p6 because it's currently got 2p4 having 6 electrons in its outer shell. So it's got 2s2 and 2p4. All right, so it needs 2 electrons effectively. Okay, then you draw out each, I didn't mean to do that. Then you draw out each atom present in the molecule. Okay, so because it says H2O, I could draw out 2 H's and 1 O. You can draw these in a line, you can draw them in a circle, whatever you feel like. Okay, so on each atom, draw a dot for each electron needed by that atom, and then you can make it into a line if you want to, extending out from that atom. So if you need to have the hydrogen, you can draw a dot here, all right? Or if you wanted to, you can draw a line, and then you got things there. Okay, I prefer lines, but dots also work because I was thinking maybe dots might be a bit better for some people. All right, so because when we talk about lines, we'll talk about other things. Okay, so your hydrogen needs 1, your oxygen needs 2. And you recognize that since it's H2O, you need 2 hydrogens. Okay, you should draw the dots in the directions of the 4 compass points, and there should be a maximum of 4 dots for any atom. Okay, so they ever need a maximum of 4, and you can draw them in the compass points, left, right, up, down, or north, south, east, west, around the atoms. Okay, so connect each of the dots from one atom to another. These lines can take many configurations, but they must go from one individual atom to another. It can be the same element, not the same atom. And there can be no dots not connecting to anything. And they must all connect so that each atom is part of a larger structure. 2 or more lines can connect 2 atoms together. Okay, so effectively what it's saying is that, okay, here is our diagram. You're going to have to connect the dots. So you're allowed to do this because it can be from one individual atom to another. It can be the same element, just not the same atom. However, if I did this, then I would be forcing myself to do this because all of the dots have to have something on it. All right, and they must all connect that each atom is part of a larger structure. But now I have one structure here and one structure there, and I've connected it to itself here. So that's not allowed. I've connected it to the same atom itself. So let's start that one again. Okay, so let's get rid of these ones here. All right. So what I want to do then instead is to do something like this. Connect that one to that one and connect that one to that one. Okay, that's the only other orientation that it can form. All right. So they're all connected. there must be no dots connected to any, there can be no dots not connected to anything, so they're all connected to something. And each atom is part of a larger structure. So this hydrogen here is connected to this hydrogen here via that thing there. Okay, and then through there. Okay, so they're all connected together. Okay, so 2 more lines can connect the atoms together, but we don't have any examples of that, so we have to see where we go. Now this is the tricky bit. You're going to try and retract the lines so that the atoms arrange themselves with the lines connecting them. Okay, so we had this diagram where I had that one joining that one and that one joining to that one. Now, retracting the lines means you do this. You make the lines shorter, but effectively you would need to bring the hydrogen across, and you end up with a short line, if you wanted to, with a hydrogen there, because that's the hydrogen that was dragged along. Okay, that's the hydrogen that was dragged along. Okay, so if I was to draw that one there, okay, so if I can, oops, where's my thing? So I can move that hydrogen, right? So that hydrogen, if I was to retract this line there, then that hydrogen, that hydrogen would move to there. That's what I mean by retracting the line. Okay, so retracting the line, making sure that my lines are now nice and straight, and now that's how they are once they've retracted. Generally, you retract them from the central atom, which is the atom which is connected to the most other atoms. Okay, that happened to be the oxygen here. So I've retracted the 2 hydrogens, and now they're connected to the oxygen that way. Now, convert each of these lines into 2 dots. These are the shared electrons between atoms. Okay, so I have 1 dot here, 1 dot here, 1 dot here, 1 dot here. Okay, these are actually the same dots that we can draw things. Now you can replace them with X's and O's, and you can be hollow O's as well, because you might want to show them that they're different electrons between the atoms. Okay, so they don't have to be dots, they can be other symbols as well, because we have to show these electrons from different places. The pairs of electrons made up from 1 electron from each atom of the bond. You should then be able to work out how many electrons are present in the diagram from each atom. Okay, so what does that mean? So far I've got that structure here. Okay, I can see that there is 1 electron that was brought to by that hydrogen. There's 1 electron brought to by that hydrogen, and there's 2 electrons brought by that hydrogen. Okay, these are how many electrons are present in the diagram from each atom. Okay, that's the next step. Then I say some atoms have electrons in their outermost energy levels that are non-bonding. Determine if any of your atoms have non-bonding electrons, and then add them as pairs around those atoms. So I'll just redraw this thing again. Oxygen, 1, 2, 1, 2, oops. Okay, now, the hydrogen only had 1 electron, going all the way back to what we started with, the hydrogen only had 1 electron. The oxygen we know had 6 electrons, but there are only 2 currently shown in that diagram. So if there are only 2, the other 4 must be these non-bonding electrons, pairs. Okay, and you add those as pairs around the atoms. Okay, so there were 6 in the outer shell. I need to have 6 that are from the oxygen in this diagram by the end of it. So I'm going to add in 4 more electrons around it. And generally you go north, south, east, west in pairs, all right? And so now you see that there is 6 electrons represented by these blue dots on from this oxygen there. Okay, so I've added the non-bonding electrons there. Okay, and that's it. And that is your electron dot diagram for something. Okay, you don't need this light blue line here, right? What you do need is to make sure that you have all the electrons there. Okay, and another way that you could show it is if you were to turn these electrons, oops, not that, this way. Okay, so you can see that I've replaced these dots with these X's there for the water. Okay, and so that is the electron dot diagram for water. Let's go back up and let's go start again. Okay, let's go start again with another element or another substance. Okay, we're going to do NH3. This might be a long video. Maybe I'll cut this short and then do half a video and one and half a video of another. NH3. I know that N has 5 electrons, and I know that H has 1 electron. Okay, that's in the outermost shell. That means that N needs 3 electrons, H needs 1. Okay, because the N needs to get to the stable electron configuration with the full p orbitals. Okay, so therefore I need to next write out what all of the atoms. So I need 3 H's and 1 N. Okay, then I'm going to draw a dot for every electron that it needs. The nitrogen needs 3, the hydrogen needs 1. I'm going to connect some dots. Okay, so let's have a look here. N. Actually, I guess I can just show this as to not having to redo this over and over again. Okay, so I can have the N. I can draw these lines in. Here we go. You can see what's wrong with this, what I've drawn. Okay, you should be able to see that I'm connecting it to itself, and then that these ones on this side are totally separate to the ones on this side. So that's not ideal. So that's not what we want. Okay, so I don't want to have those connected to itself. I don't want these connected to each other. I would prefer to do it like this. Okay, then I'm going to retract the lines. Okay, so here's my hydrogen here. I'm going to retract that along this line to make that line nice and short. And by the end of it, if I get rid of that line because I've retracted it and get rid of that hydrogen, I'm going to have a nice line here, short line there. Okay, I'm going to get rid of this, retract this line, get rid of that H there, have a nice line here with another H here. Then I'm going to retract that line here, retract this line, and bring that hydrogen all the way back over to here, and I'll have a single line connecting it. Okay, so that's the retracting of the lines. Then I need to replace each line with a pair of electrons. Okay, so pair of electrons. Here I've got 1 pair, 2 pair, 3 pair. Okay, now I'm going to say that the O's, the circles, are brought by the hydrogens and the X's are brought by the nitrogen. So the nitrogen is showing 3 electrons. This one, and this one. Okay, so those are the 3 electrons that are being shown by the nitrogen right now. I know that nitrogen has 5 in its outer energy level, which means that I'm missing 2 electrons, which means that I'm going to draw them here and here as a pair on the top, because remember we kind of generate our diagrams as north, south, east, west. All right, so that's and then I know that hydrogens don't have any spare electrons, they've only got the 1, so that's how you draw NH3. Okay, maybe I'll go do this one more. Yeah, maybe a few more, I don't know, see how. I'm going to draw the CO2. Let's just follow these steps. I'm going to just do it quickly. So CO2, I know that C has 4 electrons, and I know that it needs 4 electrons. I know that my oxygen has 6 electrons in its outer energy level, so it needs 2. Okay, so I go draw C with 4 dots on it, O with 2 dots, and O with 2 dots. I'm going to draw these lines in. Okay, so you see that they are connecting 2 lines to each atom. So if I retract those, retract that one, and bring that oxygen close, I'm going to end up with 2 lines connecting that oxygen to that carbon, because that's how many lines connected it. These 2 lines can also connect from there, retract those lines, bring that oxygen over, and then have 2 lines here. So the 2 lines there represents two pairs of electrons, which represents what's known as a double bond, where you have 2 pairs of electrons being shared across the 2, and over here as well, 2 pairs of electrons being shared across the 2. Okay, so then I would be able to say that, okay, the carbon brought 4 of those and the oxygen bring 2 each. So we'll say the carbon has the X's. The carbon, it needs 4, right? And in the diagram, there are 4 of them that belong to the carbon. that carbon, so it doesn't need any more. The oxygen has 6, needs 2, and it has only 2. Sorry, it has 6 electrons in its outer shell. This one only has 2 electrons there, so it needs another 4. So I can do 1, 2, 3, 4. Whoops, shouldn't use X's, I should use O's, because that's what the things we're symbolizing. And then this one here as well will be O's on this one as well, because it's exactly the same situation. Okay, and that's the electron configuration for carbon dioxide. Let's have a look at another one. Let's do CH2O. Okay, so CH2O. C, I know, has 4 electrons in its outer shell. That means it needs 4 electrons. I know that H has 1 electron, needs 1. And oxygen has 6 electrons, therefore it needs 2. Okay, so I'll draw out the 1. So because it was H2O, so 1 C with 4 electrons around it. 1 hydrogen here, 1 hydrogen here, 1 oxygen here. Okay, how can I connect those? I'm going to connect them. If I connect it like that, they can't connect to anything else, so they've got to be connected to something else that has other stuff. All right, if I connect it like this, that's still not working because the last one here is going to connect to that same atom itself, so that's not working either. Okay, how can I connect these all together? Well, how about I try like this instead? Both of these to that one, and then I can have 2 lines connecting those two. Okay, so now I take that oxygen, right? Or I copy that oxygen, and I'll retract these lines and bring that oxygen over here. Whoops, where'd it go? So I retract these lines, make them shorter. Okay, until that they are just going to be right next to each other, and they're going to connect like that. I retract these lines here, bring those 2 hydrogens, 1 up and 1 across, with single lines connecting those as well. Okay, then I replace each line with a pair of electrons, so it will look something like this. Okay, if I say that the X's are the electrons from the carbon, the O's are from the, actually I'll maybe make those squares or something, so that those are from the hydrogens, and the circles are from the oxygen. The carbon already has 4, okay, so the carbon has 4 electrons in the diagram, those 4 X's there, right, so therefore it doesn't need any more. The hydrogens have also their 1 square electron, and so the oxygen needs to bring 4 more electrons. All right, you can do them top and to the left. That's how you draw that one there. All right, let's draw HPO. Okay, HPO. Okay, so hydrogen needs 1, phosphorus needs 3 because it has 5 in its outer shell. Oxygen needs 2. Okay, so P has 5 electron, needs 3 electrons, which is why I've drawn 3 dots there. Connect them together. Ooh-wee. Okay, this hydrogen gets drawn nice and close to that phosphorus with a line there, and then these lines get retracted, pulled in. Since there's 2 lines connecting that P and that O, okay, I'll draw 2 lines connecting that P and that O. So therefore I replace each of those lines with a pair of electrons. Okay, we'll say that the X's belong to the P. P has 3 electrons in the diagram, so it needs another 2 more because the P's have the X's. So there's only 1, 2, 3, so it needs 2 more to make 5 because that's how many it has in the first place. Then oxygen, again, it has 2 in the diagram. There's 2 circles here and here. So I can draw another 4 there. Okay, that's HPO4. Okay, or HPO. All right, so I might do the others later on as another example video and maybe a few more as well. But that's how you generally do that process. You can watch that over again, and then I would suggest that you find questions to practice. Adios.